Welcome to the pre-class video on thermodynamics. We're starting a whole new subject.
Okay.
And the key, what we're going to start with, is kind of the big idea from this chapter. Entropy.
Entropy?
Entropy.
What is this entropy?
What is entropy?
Entropy is chaos, basically.
Basically. Although some people would get upset if you use the term chaos, because there's a technical term for chaos. And so most physical chemists would prefer that you use disorder.
Okay.
What entropy is disorder.
Right.
Right? So what do we mean by disorder? Well, what do we mean by order?
Well, when things are in order, they're all nicely lined up. They're how they're supposed to be.
Organized, kind of.
Sure. Yeah.
When they're disordered, it's more like randomness. It's like random motion, random organization.
Right, you can think about it as your room at the beginning of the semester and your room during finals.
Okay, that sounds good. Or you can think of it like an ice cube, nice and fixed and solid and rigid.
That's order.
That's order, organized. In fact, like snowflakes, they're very organized. They have, a very specific shape and they're always hexagons. But if you melt that ice cube or melt that snowflake, it doesn't have that structure anymore. It's kind of all flowing around, moving, right?
We call that water.
We call that water. So it goes from a solid ice cube, which is fairly organized and ordered, to a liquid, which is kind of flowy and can move around, and that's more disordered, right? So that's an example of a chemical system, right? The symbol for entropy is S. Now, why do you think it's S instead of something else?
I have no idea.
Neither do I.
Maybe it just looks really disorderly.
Yeah, it probably has to do with like German or something.
Yeah.
But E was already used for energy, and so we couldn't use E. What we're going to be concerned with really is delta S, a change in entropy. And it turns out that for processes in the universe, an overall process, we will always have a positive delta S.
Which means that things will always get more disordered.
Right. That's a natural tendency in the universe.
Yeah, it's the natural tendency of my room. So.
Right. In fact, some people think that that's basically what time is that what we perceive as time is the universe increase in entropy. Time moves forward, doesn't move backwards, and that's very unlike most natural systems.
Yeah, there you go.
So we're going to be dealing with this idea of entropy and trying to develop what it means in a chemical sense and use some of your common sense, because we actually, even though it's a technical term, we actually kind of know what it is. We have a feel for it.
Right.
Okay? So very brief little introduction, terminology, symbols, and we'll see you in class.